Okay, so do you have any questions? How are you so far? Let me let Garrett in.
Doing pretty good on it.
Likewise.
Now you do know that you got to start, you have to have a formula sheet, right?
Yes, ma'am.
Okay. So Jared, you're coming in, and Garrett, you are.
Hey, how you doing?
Fine. How are you? Let me let
Doing
Bree
well.
in here. I feel like I'm taking roll like I usually do in class. So we're going to be looking at section 3.4 today. I'm going to be talking about it, doing some problems, and showing you how to use your calculator. The last quiz, you've only got one quiz left, and that's due by the 23rd. And I know of a couple of people that have already completed it. Please make sure you have your formula sheet. And I just want to reiterate that I will not grade your test until I get your scratch work, and that does include your formula sheet. There'll be a grade of 0 until I get that information. I've got another class, and I still have 2 people that have yet to give me their scratch sheets, and they've got 0s. Maybe they'll wake up to it. I don't know. I haven't figured that one out yet. But in section 3.4, let me get the formula out here. It talks about present value of an annuity or amortization. Now, you've got to see this because it's different from any of the formulas that we've had so far. You've got the present value of an annuity is the lump sum, one-time deposit that can be deposited today. Remember, I told you I like that P because that's presently, that's the lump sum, that will equal the same final total that a series of equal periodic payments would make. Okay, R is our new value that we got from the last section, and R refers to payments. Now, one use of this is if you borrow money to buy a house or a car, then you're paying the bank, like I said before, back not only the interest, but also what the money, if you had not borrowed it, would have grown to. So that includes the interest and everything. This does not tell you a final amount in the future. So that's your new formula. The exponent up here is a negative NT. The little r, little n, little t is the same things we've used before, but that is a negative there. If you don't have that, then it really messes up the problem. Now on this particular page, here's a use of this formula or this type of situation. On retirement, a couple wants to make a lump sum investment paying 8% compounded annually. Now notice it says they want to make a lump sum investment. That would be a P. So they can receive annuity payments of $10,000 at the end of each year. Anytime you see a payment or annuity payments, that's your R value. So this is why I went to this formula, because the question is, how much should they invest today in order to receive that $10,000 at the end of each year for the following 5 years? And I see that my time sign didn't come out, so that should be a time sign there. So they would need to invest that $39,927.10 in order for them to get these equal payments for the next 5 years. Now, in order to see if these values or these amounts are true, then you either have to go back to a compound amount formula for this, because that would be my p-value in order for me to find out what that would be. But for an ordinary annuity, if payments are 10,000, then I would have to go back to this formula. These are two separate problems. That one formula up here only relates a lump sum with payments. That's all. What is either borrowed or put in today. And this is the amount of payments. So I would have to use this up here. Let me put my present value in. My interest rate was 8%, and it was compounded annually, and it was for 5 years. And be careful how they want you to round. So if I'm going to the nearest, which would be cents, I would have that. In this one, find the ordinary annuity. I'm looking for my S. Payments were 10,000. Interest rate. I need to type this in right. So if you'll notice, they are the same. If you put a lump sum in of that amount or payments for 10,000 under the same conditions, they do come out to be the same. So in a way, this couple, their last payment they get is just totally based on their interest. Oh, Brienne. Sorry, I thought I had Brienne in. Sorry, Brienne. But normally, I don't have you prove this. I just need you to be able to look at the problem and reading it very carefully what you have to do in order to answer the question. Now let me look at number 1 down here. eLoan recently offered a 36-month auto loans at 9.84% compounded monthly to applicants with fair credit ratings. If you have a fair credit rating and can afford monthly payments of $350, how much can you borrow? Now, when you're borrowing from a loan agency, a bank, credit union, whatever, you're borrowing P amount of dollars that day in order to either get a car loan, RV, house, whatever. But we need to see how much can we borrow with respect to monthly payments. So I know we can do $350. Monthly, remember, is 12. Be careful. I've had people put 36 in. But what is T in terms of? Can anybody tell me?
It's going to be 3.
It is going to be 3 because it's in term of years. So you just have to read carefully. Now I'm going to do this problem similar to what I've done before. Let me see if I can make my camera go up a little bit and not irritate it, which I normally do. No, it's not too bad. All right, so 0.0984 divided by 12 stored in for X. You always do the numerator. My calculator will catch up, I hope. There. So 1 minus parentheses 1 plus X raised to the negative 12 times 3. I'm still in the numerator, which means I'm still in my bracket. I need to divide that by X. I stored that earlier. That number right there, the 31, is this number inside my bracket. So let me multiply that by 350. So what we could borrow from these people, because we have a fair credit rating, we could borrow that much. Y'all okay with that?
Yeah.
Now, a loan is amortized if both principal and interest are paid by a sequence of equal periodic payments. Normally, you will know how much the loan is for, and you have to find the payment necessary to pay off, it's called amortize, the loan. Now, the formula we had just a moment ago. Now, if I need to find my payment, I could use this particular formula. I would find the value in here, and then I would divide both sides by that, and I'd end up with P over that is equal to R. So if you want a different formula, you can, but this is still the same old formula that we had just a moment ago. I'm just looking for, in particular, payments. Is that okay?
Yeah.
Now, the way you're going to have to go about doing this VI calculator is the exact same way if I use this formula. My finger will show up in a minute. There it is. So let me look at number 1. A recreational vehicle costs $80,000. You pay 10% down and amortize the rest with equal monthly payments over a 7-year period. If you pay 9.25% compounded monthly, what is your monthly payment? That right there tells me I'm going to be finding R. How much interest will you pay? Well, we have to wait for that. But guys, we're borrowing money today, which is a P. So the only formula I've got that relates P and R is this formula right here. This is why you've got to read very, very carefully. Now, there's another situation in here, and you've got to understand this. That I just underlined. You pay 10% down. What does that mean?
Go put like 10% of the loan you're taking out.
Yep.
towards the
If
bank.
you, yeah, that's yeah. If the recreational vehicle costs $80,000, we're going to take 10% of that to see how much we're putting down, which means that's money I'm going to give them right now so that my loan will be less. in order to buy a house, pretty much you have to do that. You have to pay anywhere from 20 to 30% down in order to get a loan for a house. So if you do your 80,000, subtract 80,000 times your 10%, so they're actually getting a loan for 72,000. So the p-value is going to be 72,000. I will go ahead and use this formula that I've got up here because we are asked to find monthly payment. We're borrowing 72,000. Raised to the negative 12 times 7. If that's all right. Let me know if it's not. Where I start is going to have to be down here in the denominator because I've got to get the denominator a single number. Again, I'm going to put R divided by N and store it. And I start with my brackets, with the numerator in the brackets. That's my numerator. Let me divide that by X. So I've got that. Are we okay so far?
Yeah.
That number is down here. So I'm going to go 72,000 divide by second answer and see if you come up with that. Are we all right, guys?
Yeah.
Yeah.
All right. Now here comes the interest. If you're ready for this, the easiest way to find the interest, find first, well, I'll just write down, we're going to do our payment times how many times in a year times number of years. Remember, we're doing a monthly payment for 7 years. And then finally, I'm going to subtract off what the original principal was. Let's see what happens. So in all, what they're paying back for this recreational vehicle, $98,075.88. I usually have people concerned about this, but you've got to understand this is a monthly payment for 7 years. You have to find out how much are you paying back in all. Yuck. So is that one all right, guys?
Yeah.
Now, the next problem. A family's thinking about buying a new house costing $120,000. This was some time back. The family must pay 20% down, and the rest is to be amortized over 30 years in equal monthly payments. If money costs 7.5% compounded monthly, what will the monthly payment be? How much total interest will be paid over 30 years? All right, now we saw down payment a moment ago. So go find, what I'd like you to do first, go find how much they're going to borrow from the bank. And let's see if we agree. I came up with 96,000. Does that sound right on your all side?
Yeah.
So we're going to go find the payment. Borrowing 96,000. So go find what the payment. We'll see if we agree. I came out with $671.25.
That's what I got.
Is everybody all right?
Yeah.
Yes.
All right. So that's the monthly payment. How much total interest will be paid over 30 years? Go find interest. And I'll write down what I came up with. Getting a house is an investment because you could turn right around, and sell it. You can't do that with an apartment. But guys, this is sad. 145,600. That's more than what their original money that they borrowed.
That's why you never take out more than a 15-year loan.
Mm-hmm. I do want to change this just slightly. And instead of 30 years, let's just try 20. Let's just see what would happen if my time was 20. So everything pretty much is the same, except I'm going to have 20 right here instead of 30. Is that all right?
Mm-hmm.
So I'm going to imagine 20 there and redo this problem. I'm going to find out what the monthly payment would be. And I came up with so a tad over $100 extra. So maybe this, the family decides to put in an extra $100 on this. They'll have it paid off in about 20 years if they do that. Just anything extra would help. But I'm going to find the interest if they did it for 20. That's a big difference to me. So guys, interest rate is a lot different now. It is lower. But if you can do it, 30 years is terrible because you will be paying over double the amount of whatever the loan is that you're taking out. And look at different scenarios. When we bought this house, I went and I used this formula just to make sure that the bank was right. Sorry, I'm like that. And they were. But if I showed them that formula, they couldn't do it because it's completely on computer now. They just type in the thing, the values of everything, and it spits it out. But that's the formula that was used to figure out the payment depending on the loan that I got or we got. Now, one more thing. Because a lot of people, back when interest rate changed, they went and got a different interest rate. So I want to look at this and see how we can figure out what the unpaid balance was, because that way I'd be able to tell how much do I still owe, okay? And then maybe change the interest rate, see if it would be beneficial. So an unpaid balance of an amortized loan. The unpaid balance of an amortized loan is equal to the present value of the remaining unpaid payments. Since the payment's already known and the amount of time left is known, then we can still use the present value of an annuity formula. Solving for P will tell us the unpaid balance. So let me put my formula back down. I had it on the other page. So first thing we're going to have to do is, we know the loan, it's a 20-year for 6.75% compounded monthly. We got to find the monthly payment. Once we do that, then we'll do the rest of this. So I need you to go and find the payment. And we'll see if we agree. And when you get it, see if you came up with what I did.
Yeah.
So everybody's all right?
Yeah.
All right. So let me show you how simple these are. They're not bad at all. We found the monthly payment. We're going to go find the unpaid balance. Well, the unpaid balance is my P value. So let me put down my payment. Now, this is after 5 years. Well, guys, after 5 years, that means there's still 15 years waiting that I'd be paying on this. So I'm just looking what has happened. You know, the 5 years has gone on by. We've paid stuff in, and this is going to tell me what is left on the loan. How these other ones differ down here for 10 years, I would have 10 instead of 15 here. After 15 years, I'd have 5. So see what you come up with this one for this particular problem, and we might do B and see if we're all right. So I came up with $180,443.32. So if they go in and they want to try and get a better interest rate, then they would know what they would be looking at. And were you all right with that particular thing?
Yeah.
Try 10 years. But I have to go through the whole thing again. No. All right, guys. So Wednesday, we'll be looking at the review in my math lab. If you could print it off, that would work. Or if you have particular problems. Now, I've printed it off already, and I'm going to tell you that our problems will be similar, but the numbers will be different. But they will still be similar. Have your formula sheet. Make sure double check that your variables are correct. Make sure you've got a negative with this particular formula. because little tiny things that can hurt if you don't have them. Now I'm going to reiterate again what I want on the test. You need to tell me, write out the formula. Don't tell me. Write the formula down. On this one, I would expect to see these particular numbers. But from there, everything can be done in the calculator. Then you can give me your answer. Okay? And some of y'all came in a little bit, just a tad late, but, oh Lordy, I hope I think I told it to start recording. Yes. Whew. Got panicked there. And I forgot what I was going to say. Oh, I know. After the test, I will open it when we get through with our review on Wednesday. Test is due by Monday, the 27th. I will try to have it graded as fast as I can. I will not grade them until I get your scratch work, including your formula sheet. Okay?
Okay.
Gotcha.
Okay. Sounds
All
good.
right. Your last quiz is due on the 23rd. That's over section 3.4. So to get it done, just go ahead and just get it done, get it out of the way. And I'll be starting probably on Friday. I'm going to start finding out what your tests based on your quizzes are. And I'll put that in Brightspace.
And when did you say you're going to open up the test?
On the 22nd, right after the review.
Sweet.
So you have from the 22nd to the 27th to get it done. And the sooner you do it, the sooner I'll grade it, and I'll let you know what your semester average is, because some of y'all might not be taking that final, because the final is optional.
Awesome.
Okay, guys, are there any questions?
Nope.
Nope. All right. Well, if there's no questions, then get ready for Wednesday with any questions you have about the review. And that'll be it for today.
Sweet.
Thank you.
You
Have a
are
good day.
welcome.
Have a great day, Miss Ammons.
Thank you. You guys too. All right.
All right.
Bye.
Bye-bye.